Every time you visit a website or interact with a web application, there is a constant back and forth between your browser, which is the client, and the server. This conversation happens via HTTP, which stands for Hypertext Transfer Protocol. And when your browser sends a request to a website, the server basically responds with an HTTP response code to tell you what is happening. It's like the server way of saying that, hey, what is going on with your request? Alright, after that we have 4xx, which is client errors, and these basically codes mean something went wrong on the client side. Maybe you typed the wrong URL or the data that you sent was not valid. The most famous one is of course 404 not found, which means the page that you are looking for does not exist. Why are HTTP response codes such a big deal? Well, they are not just for developers, they impact anyone who interacts with the website and web application. Let's break down why they matter. First, they help you debug issues quickly. When something goes wrong with an application, the HTTP response code can tell you exactly what happened and where the problem is. First, use tools like Postman or curl to check response code. These tools are incredibly useful when you are working with APIs or debugging web application. Hey everyone, I am Sahib Kumar and welcome to PrepTrain. If you are new here, PrepTrain community is dedicated to helping students and freshers level up their engineering skills. At PrepTrain YouTube channel, we focus on making backend development easy to understand with practical insights, real-world example, and step-by-step guidance. Whether you are just starting out or looking to sharpen skills, you are in the right place. Now, in today's video, we are going to dive into a critical topic for any backend developer, HTTP response code. These codes are essential for understanding how servers basically communicate with browsers, and then they play a huge role in debugging, API development, and improving user experience. So before we jump into the details, make sure that you hit the subscribe button and turn on notifications so that you never miss out any of our upcoming videos. Trust me, you don't want to miss out on the valuable content that we have got planned just for you. Also, if you are looking for more resources, job opportunities, internship, or just want to connect with other developers, join our Krypton Telegram community. It's a great place to stay updated and grow your network. By the end of this video, you will not only know what these HTTP codes mean, but also understand how to use them to solve real world problem in your project. So let me just grab my deck and then we will dive deeper into HTTP response code. Alright, let's start by introducing the concept of HTTP response code, something you have definitely come across whether you knew it or not. Every time you visit a website or interact with a web application, there is a constant back and forth between your browser, which is the client, and the server. This conversation happens via HTTP, which stands for Hypertext Transfer Protocol, and when your browser sends a request to a website, the server basically responds with an HTTP response code to tell you what is happening. It's like the server way of saying that, hey, here is what is going on with your request. For example, the most famous one is probably 404 not found. So you have likely seen this when you have tried to access or visit a page that does not exist anymore. It's the server way of saying that, sorry, I can't find that what you are looking for. But HTTP response codes aren't always bad news. For instance, when everything goes smoothly, you will get a 200 OK response, although you don't usually notice it because it happens behind the scene. In this video, we are going to break down these codes so that you can understand them better and use them to troubleshoot issues in your web application, whether it's client-side error, server-side error, or just informational messages. HTTP response code are your best friend when it comes to debugging. Now let's take a deeper look into how these codes are categorized. Alright, so HTTP response codes are grouped into 5 main categories, each starting with a different number. These categories help us quickly understand what type of response the server is sending, and they make it easier for us to troubleshoot issues. Let's break them down. First of all, we have 1xx, which are informational codes that basically tell you that, hey, we have received your request and we are working on it. So it's like the server way of saying that, hold tight. Secondly, we have 2xx, which stands for success messages. These codes are what you want to see, and they mean that your request was processed successfully. For example, a 200 OK means everything worked perfectly, while a 201 created basically means new resource was created, like when you post something on social media. Then we have 3xx, which stands for redirection. These codes basically tell you that you need to look somewhere else for the resource. 301 basically means moved permanently, like the resource has a new permanent URL, while a 302 found basically means that the move is temporary. Alright, after that we have 4xx, which is client errors, and these basically codes mean something went wrong on the client side. Maybe you typed the wrong URL or the data that you sent was not valid. The most famous one is of course 404 not found, which means the page that you are looking for does not exist. Finally, we have 5xx, which are server errors. These codes tell you that the server messed up. A 500 internal server error is a general error when the server can't process your request due to unexpected condition. Knowing these categories is super helpful when you are debugging because it helps you pinpoint where the problem is, whether it's on your end or the server. Let's move on to explore some specific codes in more detail. Now let's dive into success code. So these are the code that tell you everything went well and they are part of 2xx family. The most common one is 200 OK. This is like getting a green light. It means the request was successful and the server returned the correct information. You see this every time you load a web page or successfully submit a form. Although it usually happens so quickly that you don't even notice it. Another important success code is 201 created. This one is particularly useful when you are dealing with APIs. For example, when you post a new photo on Instagram or to create a new resource in an app, the server basically sends back a 201 created message to confirm that the resource was successfully created. These success codes are essential in backend development because they ensure that everything is working as expected. When you see a 200 OK, you know the request was processed successfully. And when you see a 201 created, you know that a new resource was added to the system. Success codes basically keep everything running smoothly behind the scene, and knowing what they mean helps you verify that server is doing what it is supposed to do. Next, we are going to take a look at redirection codes. Alright, now let's talk about HTTP redirection codes, which are part of 3xx family. These codes indicate that resources that you are trying to access has been moved. But don't worry, it's not lost. The server is simply telling you where to go next. The most common redirection code is 301, which is moved permanently. This means that the resources you are looking for has been permanently moved to a new URL. For example, imagine that your favorite blog has changed its domain name. So if you try to visit the old URL, the server will send you a 301 moved permanently response and automatically redirect you to the new URL. It's like finding out that your favorite coffee shop has relocated across town. You will still get your coffee, but just at a new place. Then we have 302 found, with this is temporary redirection code, meaning the resource that has been moved but only for a short time. Think of it like your coffee shop is closed for renovation, but they will be back soon. But for now, they have set up shop temporarily somewhere else. The server will basically redirect you to this temporary location, and once things are back to normal, request will go to the original location again. Redirection codes are crucial because they ensure that users are directed to the correct resource even when things change in the background. They help maintain a smooth user experience by avoiding dead ends or broken links. Now that we have covered the redirection code, let's shift gear and talk about client-side error, which can be a bit more frustrating. Alright, now we are moving to the client-side errors, which fall under the 4xx category. These are the errors that happen when something goes wrong with the request sent from the client. It could be a typo in the URL, bad data, or missing credentials. First up, we have 400 bad requests. This error occurs when server can't understand or process your request because the data was invalid. It's like trying to ask a question, but your words are all jumbled up and the server simply can't make sense of it. For example, this could happen if you are sending incorrect or incomplete data in a form. Next, we have 401 unauthorized. This means that you are trying to access a resource that requires authentication, but you haven't provided the necessary credentials. It's like trying to enter a VIP section at a concert without a ticket. You need to log in or provide a password to gain access. Then we have 403 forbidden. This means that even though you are authenticated or logged in, you don't have permission to access the resource. Imagine trying to open a locked door with the wrong key. It's not going to happen, no matter how many times you try. And of course, the most famous one, the 404 not found. This means that the server couldn't find the resource that you are looking for. Maybe the page has been deleted or maybe you mistyped the URL. It's like going to a restaurant only to find out that it's closed or has changed location. These client error codes are important because they tell users what went wrong and give developers a clear idea of what needs to be fixed. Whether it's an authentication issue, a missing page, a bad data, this code basically helps pinpoint the problem. Next, we will dive into server error, which occur when something goes wrong on the server side. So let's talk about server side error, which are part of 5xx family. These errors occur when the server fails to fulfill a valid request. Unlike client-side error, which are usually caused by something wrong on the user end, server errors means something went wrong on the server itself. The most common one is again 500 internal server error. This is a generic error message that tells you that something went wrong, but it does not provide specifics. It's like walking into a restaurant and finding the kitchen is on fire. The server cannot fulfill your request until the issue is resolved, and this error is usually a sign that there is a bug or configuration issue on the server. Next up is 502 bad gateway. So this happens when one server receives an invalid response from another server. Think of it like two chefs in the kitchen miscommunicating. So one asks for one ingredient, but the other gives the wrong one. As a result, the request can't be processed correctly. Then we have 503, which is service unavailable. So this error occurs when server is temporarily unavailable. So usually due to being overloaded or undergoing maintenance. It's like a restaurant putting up a closed for maintenance sign. The server is too busy or it needs a break, so it temporarily stops accepting requests. Server errors can be frustrating for users, but they are also important signal for developers. They tell us that something is wrong on the backend, and they provide clue for where to look when troubleshooting. Now that we have covered both client side and server side error, let's take a moment to discuss why these codes are so important. So why are HTTP response codes such a big deal? Well, they are not just for developers, they impact anyone who interacts with the website and web application. Let's break down why they matter. First, they help you debug issues quickly. When something goes wrong with an application, the HTTP response code can tell you exactly what happened and where the problem lies. So instead of guessing whether the issue is with the client or the server, you can use the response code to pinpoint the problem and fix it faster. For instance, a 404 not found tell you that the resource is missing, while a 500 internal server error points to a problem on the server. Next, they help you improve the user experience. So when the user encounters issue on a website, response code can help you create more user-friendly error pages. For example, instead of just showing a generic error message, a custom 404 not found page can guide users back to the home page or suggest related content. This keeps user from feeling frustrated and helps them find what they are looking for more easily. Finally, HTTP response codes are crucial for API and error handling. So when you are building or consuming APIs, you need to send the correct response code to let the client know that what is happening. For instance, if a user tries to access a restricted resource, you should return a 403 forbidden code instead of a 500 internal server error. This ensures that the API behaves predictably and developers know how to handle different scenarios. So in short, understanding these codes is key to troubleshooting, improving user experience, and building reliable APIs. Now let's wrap things up with a few quick tips on handling HTTP code in your project. Alright, now that we have covered the essential of HTTP response code, let's wrap up with some quick actionable tips for handling this code effectively in your project. First, use tools like Postman or curl to check response code. These tools are incredibly useful when you are working with APIs or debugging web application. Let's say you are testing an API endpoint. So you want to see what response code the server sends back. With tools like Postman, you can easily send a request and inspect the exact response code that you receive, whether it's at 200 OK, 404 not found, or 500 internal server error. This makes debugging faster and more efficient. Second, always make sure that you are returning the right status code for your APIs. For example, if a user tries to access a restricted resource, don't just send back a 500 internal server error. That is too generic. Instead, send a 403 forbidden to let them know that they don't have the right permission. Returning accurate status code helps the client understand what went wrong and improve the overall reliability of your API. Finally, create custom error pages for better user experience. We all have seen the 404 not found pages, but instead of just showing a boring error message, you can just create a custom page that gives user helpful option. Maybe include links to your home page or related content or even a search bar to help them what they are looking for. These small touch can make big difference in keeping users engaged even when something goes wrong. These tips will help you handle HTTP response code more effectively, whether you are debugging, building API, or improving the user experience. Now let's quickly recap everything that we have covered. Alright, let's quickly go over everything that we have covered today to make sure that it all sticks. First, we learned that HTTP response code are the server way of telling you what's going on with your request, whether request was successful, redirected, or resulted in an error. These codes provide essential feedback. We also broke down the codes into 5 main categories. 1xx codes basically give you informational message. 2xx code basically gives you message that the request was successful. 3xx codes basically tells you that your request is being redirected to another resource. 4xx code basically means that it was a client side error like a 404 not found. 5xx code basically means that something went wrong on the server end like a 500 internal server error. We then explored some most common codes including 200 OK, 404 not found, 500 internal server error. We also discussed why these codes are crucial for debugging and improving the user experience and building reliable API. Finally, we wrapped up with some quick tips on using tools like Postman and curl to check this code and emphasize the importance of returning the correct status code in your API. Oh, and don't forget, custom error pages can really enhance your experience. These codes are not just numbers, they are essential tool for any developer working on web application or APIs. Now that you have got a solid understanding of HTTP response code, you are ready to use them effectively in your project. If you ever encounter an error, you will know exactly what is going on. And that's it for today. Thank you so much for sticking with me until the end. I hope now you have a clear understanding of HTTP response code and how they can help you troubleshoot and optimize your web application. If you found out this video helpful, don't forget to give it a thumbs up, and it really helps our channel grow and reach more people who are interested in backend engineering and software development. If you haven't already, make sure to subscribe and turn on notifications so that you don't miss out any of our upcoming videos. Also, if you are looking for more resources, job opportunities, or internship, be sure to join our Prep10 Telegram community. It's a great place to stay updated and connected with other learners. We have got more videos coming soon, especially focused on backend engineering. So stay tuned, and thanks again for watching. I will see you in some other video.